Welcome back to the Federal News Network DoD Cloud Exchange. We're speaking with Dr. Mark Taylor. He is the Chief Technical Officer for U.S. Special Operations Command. And we were talking a lot of technology, a lot of cybersecurity, a lot of cloud strategy before the break. Let's get into some of the human aspects of this, the human capital needs, the cultural needs, when an organization that is very much self-contained begins in a very big way to inculcate cloud into daily operations. That must take a lot of the people and a lot of the thinking.
Right. The only constant is change. And folks generally don't like change, but the benefit of working in special operations command, more so than has been my experience with many other DoD entities, is the fact that most of the folks that work here have been in the field. If they're not actual people that are on active duty right now, um, they are people who were on active duty. Not all of them, but a large amount. And so, what does that mean? Um, it's not uncommon to have folks that were in the Ranger Regiment or were special forces of one of the branches. And so you've got a culture, at least here, and I'm sure it's other places. So I don't want to gold plate my answer like, we're so common, so we're so special that no one else can do this, because other folks definitely can. But I'm here now, so I'll talk about how awesome it is. um, the reality is we've got folks who come from a culture who, during the last 20 years of being at war, um, are of the mindset of getting comfortable with being uncomfortable. So that's constantly growing a thicker skin. That's constantly failing fast or going into something that's hard, and either getting kicked in the teeth and picking yourself up and going back in for more and winning this time, or winning decisively the first time. So I'm not surrounded by a bunch of folks that are having their head in the sand. Does that mean that every single person that I deal with comes from that? No. We still have Eeyores, just like anybody else. We still have Chicken Littles, just like everybody else. It's just not nearly as bad as most places I've gone. So, with that huge, much larger group of folks that have a bias for action, we have a culture of folks that are willing to go and try something. Now, I would be remiss if I was to say that, since I got here, we just got in the cloud and everything awesome happened once I got here. I would love to say that. The reality is a whole large amount of years of effort down the cloud journey have been in effect for a while. And I would argue have been in effect probably since some of the earliest days of the cloud, if nothing else than to keep an eye on, well, what is that witchcraft you speak of called cloud, right? I would say that the more operationally focused aspects, the more pointy ends of the spear within Special Operations Command, the doers, not necessarily the communicators, are the ones that are pushing the envelope to try to make sure that they come to us with requirements um, to provide interesting things. And the reality is cloud provides that scale and that flexibility. Everybody knows about the scale and the flexibility of cloud relative to an on-prem capability. It's the mere fact that I don't have to get a capital expenditure to buy $5 million worth of stuff and then start beginning to figure out how to extract value of that bunch of bare metal. It's the fact that I could go to a pre-set up data lake or pre-set up, multi-million dollar server and put in an answer and have it crush that answer and get it for me in like an hour, pay 10 grand or 5 grand. I'm completely making up the number. But then turn it off when I'm done. And my investment was X versus, it would take $10 million or $1 million just to buy the hardware, then get my answer, and then I now have to figure out what to do with this big paperweight for the next year or two. That is what our folks, this formation has gotten after. They're actually extracting the value, have been extracting the value of a lot of these things, whether it be, some computation or whether it be utilizing, data science or anything that you would think of that's just a trope at this point in 2023 of what the cloud can provide you. It provides you that scale. It may be expensive and it may be sticker shock to some, but relative to what it would cost to go buy all of that, it's a deal. So back to the whole being good fiduciary responsibility, responsible custodians of the government's money. We're actually providing more value in a quicker amount of time for a cheaper cost. Now, over time, that will probably become some kind of linear or spiky model, because as you start seeing value, you're going to see more investment. So you're going to see more people doing more with it. And so that now creates its own problem. Over time, I might see my cloud go up while my on-prem go down. Okay, that's probably a good problem to have, but these are the things that we're finding by actually going out there and doing that. The other part, or the final part, I'll say, in terms of the people and the approach, is we've got a very robust training program and training opportunities that are available to the folks here. So, for example, most of the military forces, Space Force, Air Force, Navy, Marine Corps, Army, have training that's offered to them by training providers. I could be wrong, but I think like Udemy might be one example of that. But then also at this command, we have training that is provided, and a lot of it might be specific to something that would help garner a certification. A lot of folks say, well, what if we train them and they leave? And then obviously the savvy CIO would be like, well, what if we don't train them and they stay? The fact that we have a lot of active duty military folks makes that kind of simple, because they're going to, one way or the other, they're going to be gone in about 2 to 3 years, as they PCS or retire, or just leave the service and go on and spread that knowledge that they've gained here out. If you're a special operator, well, you're always going to be at SOCOM. But if you're a special operations communications person, you can kind of loiter, but sooner or later you will go back, or here and there, go back to the main force, like big Air Force or big Navy. Well, all you're doing is you're now taking all of these skills with you, pushing them out, and then becoming great advertisement and recruiting to get people who want to come here. So we have found, and when I say we have found, that this has been communicated to me, so I'm saying it like it's my statement. We SOCOM have found great value and great benefit in investing in our people. General Fenton, our commanding general, his big thing is people, win, transform. So you can't win unless you've got the people. So I find it to be very interesting. So people are everything. I hope that answers your question.
Yeah, I think so. And which means that you need people flexible that can take new technologies and new approaches to things, which brings me back to the technology side of this. And that is 5G as a communications medium, as an Internet of Things medium, and as something enabling software-defined networking, security as a service. All of these things we hear are enabled by this. What are you looking at in the communication space, specifically on 5G, but maybe some of the other things coming along also?
Right. So again, we look at everything. I would not say that we favor anything more than the other. And for some of those things, you probably want to talk to Chief Ryland Knight at some point in the future. If you want to go down those paths in very discrete order. 5G is definitely something we've been looking at for a while. The benefit of being SOCOM is specials in the name. So we've got a lot of cool, whether it be commercial entities or government entities that want to talk to us, like DARPA, NSA, groups that are working on experimental stuff, sometimes before they become a new thing. So I would dare say we were working with 5G back when 4G, before it actually came out. We look at utilizing 5G, but we look at using anything else. I think the big thing that we have to be cognizant of whenever we look at any transport medium such as 5G is what are the security holes that are inherent to the architecture, to the technology, and how do these technologies risk being exploited and exposing yourself? And so I think that those are some of the things that we investigate, and we're looking to make sure that we operate within proper bounds. I think it's probably as much as I can really talk about that.
Yes, because vendors do make claims and they tell you this is secure and this does this and that, but it sounds like you need almost an independent validation and verification, test and evaluation. There's lots of words for those processes that you maybe in a more intense way, being special forces, need to bring on these technologies before you can feel comfortable with them tactically.
Yeah, that's definitely true. I mean, there are a number of open to industry, not conferences, but I would say huge demos, in which case different vendors would come out and in front of the Department of Defense, and they would show their wares. So here goes satellite communications. Can you see it? Can you detect it? Here goes 5G. Here goes RF, HF. All the different radio waveforms. And as well as regular discrete circuit penetration, and then um, we put them, and when I say we, I'm talking about Department of Defense, put them through the paces. Does it do everything that your box says that it can do, or your website says that it can do? Okay, cool, block checked. Now you at least can say what you can do what you say that you can do. But then it's a matter of going into it and looking at it from the perspective of the adversary. So back to your earlier cybersecurity question and posture is like, okay, uh, how do you break it? What are the holes? What do we have to do as mitigation strategies to overcome some of the weaknesses of this technology? And then what are the things that if we were to use telecommunication source X, how do we mitigate that? And mitigation can be done through any number of different ways. Whether we just tell them, hey, patch this, that's the easy button. So you make them fix it for you, or you might have to buy a completely separate widget to go with it, and now you might be good. Or it could be something as simple as a your how do you operate it? How do you do things? So I think that's about as much as would be probably useful for the purposes of this conversation.
Right. We understand that there's strictures under what you can say and what you can reveal about inside under the covers there. But when you talk about a thing like software defined networking, clearly that's a technology you're employing, as you mentioned earlier, when you make those uh, virtual machines, if you will, that run offline and containing all of the networking and data and application resources in one blob of software. That's part of that. I mean, those technologies enable that.
Right. So I mean, software defined X is has been a buzzword for over a decade. Whether it be software defined storage, software defined networking, software defined routing, software defined whatever. Um, because the reality is the way things are going, many things can be overcome and obfuscated and projected based off of a software. The great benefit of the whole software defined networking is the fact that in normal telecommunications, you have data plane traffic and control plane traffic. And the control plane traffic is what you don't see. That's the protocols working with each other so that they can establish, this end-to-end experience between maybe 50 different hops, right? Well, we don't care about, router 49 was talking to router 43. That's the control plane traffic. Data plane traffic is what we cared about. Like, did my text or my email get through? So the great nirvana of software-defined networking and routing and all this other stuff is the fact that you can offload that control plane traffic to some kind of VM or server and basically recoup more bandwidth.
Mhm.
There are definitely a lot of other things on it as well, such as interesting traffic engineering, shall we say. Um, I think the big part of that is also trying to see where the big vendors are going to lie. Because if it's software defined, well, now there's nothing to stop you probably from creating your own, your own thing, but then you need to make sure that everything you're talking to can participate in it. Otherwise, it's just some session that's going forward, right? So it offers a lot of interesting things. Back to the whole containerization discussion earlier, with software defined X, well, now those are capabilities that I can containerize and put into a container, so that now I might be able to move. Again, it would be a fat container, but yeah, you could move like a little mini network, a little mini system. I mean, it's probably definitely a lot more dumbed down than that. But my point is these, things, microsegmentation, gets into all of the buzzword bingo kind of category. Um, but the whole software defined catalyst is creating that space, and it's creating these communities to utilize this technology to extract more value out of the systems that you have. So for example, um, and this is a real world example, when I was at the Pentagon 15 years ago, uh, maybe longer, but I'm not going to date myself. So we'll just go with 15 years. The core backbone at one time was 100 meg, which
Sure.
seems completely crazy now. But when doing a bandwidth analysis, the bandwidth utilization was like 10% of a 100 meg backbone, and you're talking about the Pentagon, right? In which case it would spike up to like 30%. All right. And so then I remember when we upgraded it to a gig backbone, right? A factor higher. Guess what? The bandwidth utilization was like at 10%. Traditionally, that's just how networks are until they spike, right? And then that's how TCP/IP traffic is. It's burst traffic. So people think if I get a gig link, I'm going to talk a gig. Well, first of all, the optics or the electronics that are at your end device probably don't even go a gig. They probably go 700 meg, maybe 800. I've rarely seen devices that truly will give you that full gig. And a gig is even a small amount I'm talking about right now, but let's just go with it. So on average, you might be on a steady state hitting it for like 100 meg out of your gig. All that gig does is it allows you, when you burst traffic for TCP/IP, to send something through. So what does all that mean? That software defined space is trying to figure out, how can I extract the value out of that delta of this unused space and actually oversubscribe existing links. That's that nirvana of what that's going to bring for us. And so those are things that we're looking at it, because again, we prosecute war oconus, not in nice places, in which case the links that we do get, if we get a link at all, are probably not the best. They're not the most reliable, and the bandwidth is probably constrained, and it may be shared. It may be shared bandwidth. So these are the reasons why the whole software defined thing is really exciting.
Well, as long as you can get those PowerPoints through the network and stay ahead of that, I guess in the Pentagon, that's probably a good thing. And let's talk about information sharing. There's classified, there's unclassified, there's intelligence data, there's protected but not classified data, and so on. How do you manage data movement, data sharing with other military units and maybe with contractors in the environment that you do operate in?
Right. So, I mean, so the different classifications are just separated to just they're just different networks. So it's not like I have a phone and I can call someone in California, but then I could also call somebody in New York. Um, if you're on classification X, you're only talking to people in classification X. And so, and then only the people that have the need or the requirement to be on that network would be able to talk on that network. So at face value, it's a pretty primitive, but very logical and capable system. It presents its problems when you want to keep adding people to the list of, who can get to the party. Well, your name is not on the list, sir, so you can't get into this party. So those are where, I think more action is spent, more effort is spent, is trying to vet and get people on the guest list to get into the party, shall we say.
But it's fair to say that the cloud that is not on premise can support the architectures and the protocols you have for sharing, even though they are out there somewhere.
Right. And again, they are built with government oversight. So all of those are, and again, I don't pretend to understand the specifics of the how. I just know that, Amazon, Microsoft, Google, Oracle, they're in partnerships with the DoD in order to create facilities to get accreditation to operate at. So if you have a secret cloud provider, you can connect to that secret cloud provider via your secret network or something like that. And all of that can be found, on the websites.
All right. And just let's wind up with a quick question about where you're heading with cloud for special operations, special forces.
Right. So the cloud, in many different ways is already being used. So using things like Office 365, you might see or hear a lot of hubbub from Joint Staff and from DISA about tenants and all these things. So right there, boom, we're in the cloud. We've been in the cloud for 2-3 years, if that's what you want to look at it. But those are things that you don't fight war with Exchange and SharePoint. I mean, I guess you could, but I mean those are like commodity.
The enemy to death, right?
Right. Death by PowerPoint, right? So those are things I would consider not necessarily war systems, right? Those are just collaboration, communication, a garrison type thing. In terms of utilizing cloud in operations, you could use the cloud to deploy an application that you want to use that might be germane to whatever you're going to do. If that makes any sense. Which is, again, the reason why anybody would use the cloud in the first place. I want a capability that I want to spin up, whether it be in perpetuity, or I want to spin up something, again, and this is the benefit of the cloud, which is the main selling point. I want to spin up and I want to use something that normally would cost me $10 million of capital expenditure just to buy into the hardware. Then I have to deal with a operational expenditure of maintaining it. Whereas with cloud, I can go right into an OpEx model and pay for what I use. So, I use some data lake, I use some compute, I use, some web servers, I use some storage, whatever. For a week might be I'm making these numbers up, $50,000, which, that's a lot of money, but relative to the $10 million of startup costs, that's a bargain and a half, right? So you spin, and the assumption there is I have people that know what they're doing, right? So the assumption is I have cloud engineers who know how to operate and manage the cloud, but then I also have data scientists or somebody who knows how to operate a data lake or write an application or create a CI/CD pipeline so I could deploy code or build a web front end. All the IT stuff. So assuming I have these people and I have the money, I have at least 50K, right? And I use it, I build the gonculator, I get my answer out, and now I turn it off when I'm done. And hopefully those people that did all of that stuff in this grand opera, this chorus that we just put together, this orchestrated mechanism will go on to other jobs or back to their day job or wait for the next opportunity to come up. Those are things that we look at.
I think we're going to close on thinking about the gonculator. And that's thought we'll take away with us today. Dr. Mark Taylor is the Chief Technical Officer for U.S. Special Operations Command. Thanks so much for joining us.
Thanks for having me.
And I'm Tom Temin. You're listening to Federal News Network. Let's go back to the studio now for more of the DoD Cloud Exchange.